everyone, we are going to present you our third evidence of math. Our team is Alexa Cristina, me, Andrea Bustos, and Noemi Natalia Aparicio.
Instagram. It's a graphical display of data using bars of different heights. It's different about the bar graph because Instagram uses a quantitative data. Now the example. Those are the given data. This number we can get it because it's the number between those numbers. So 55 is the number between 50 and 60. 65 is the number between 60 and 70, and so on. This is a frequency. We can get it, the frequency, with the whole data. So all this chart, all these numbers, we can have in this graph. So the 55 is in here, and it's in the 8. So this is the 8, 55, and 65 that have in here, it's in the 10. So the graph is also in there. The bar, it's also in there. So we can have the histogram with this data. We also have in this graph the frequency polygons, that it's the same data just with another graph. So frequency polygons are a graphical device for understanding the shapes of distribution. They serve the same purpose as histograms, are especially helpful for comparing sets of data. This is an example. It's the same as histogram, but the chart or the table is different. It's the same like XA, XE, I, XI. It's with the data. We have this number with the whole data, and the FI, it's a repetition of this number. This is a graph with the frequency polygons, and we can see that the 13 is in the 3, and the 14 it's in the 1 because it's just one repetition, and so on. Now the example. This is the same as histogram, but it's a different table. XI, it's the same. We have this number with the data that are given, and the FI, that it's a frequency, we have this number with the repetition of this number. So if it's 13, we have 3 repetition of 13, and 1 repetition of 14, and so on. This is a graph, and we have this data in this graph. So 13 it's in the 3, 14 it's in 1, and 15 it's in the 5 because it's 5 repetition, and so on. So this is. Más.
Ok, 1, 2, 3, ¿ya? ¿Puedo seguir hablando? Okay. It's a type of frequency polygons that shows cumulative frequency. It's kind of the same of histogram, but instead of use rectangles, it is give as a single point marker, like this. So to get a give, you always going to have the class limits, which is this part, and the frequency, which is this part. It's given percent. So to have the relative frequency, you are going to have the first frequency between the summatory of all these ones. The summatory of these ones are 25, so you are going to have 5 between 25, which is 0.20, and so on. The cumulative frequency is going to give, it's the summatory of the first digital added to the second digital. So in this case, it's 5 plus 5 is 10, 10 plus 6 is 16, and so on. Cumulative frequency is the same of relative frequency. You're going to have 5 between the summatory of this, which is 25. So 5 between 25, it's 2.20, sorry, and so on. Then you're going to graphicate so this way. So 1 to 9 is 5, and the relative frequency is 0.20. So it's 20 in percent. You're going to have it like that. Then it's added another 20, and it's 40. Then you're going to go to another 24, which is in 16.4, and so on. So I'm going to explain you the bar graph. It's also called bar chart. It's a graphical display of data using bars. It's kind of the histograph, but the difference is that in this one you're going to use qualitative values. For this, in this example, we have the color of the hair. We have blonde, we have ginger hair, and we have brown. In this part of the bottom, we are going to have the qualitative values, and in this one, we are going to have the number of persons. In this case, the number of persons with blonde hair is 6, which is over here. And it's 4 in ginger hair, it's here, and brown hair, it's over here.
Okay, here we have the example. In this case, we can see that we have the number of centers of each state. So in order to obtain the average of each state, of each center, we use the rule of 3. For example, we have 180 is equal to 1 or 100%. So we multiply 30 for 100 and divide the result into between 180, that is equal to 16.7%, and so on. And now we also use the rule of 3 in order to obtain the angle. So 1 is equal to 360. So we multiply 60.7 to 360 and divide it into between 1. So we have all the angles, and we make the pie graph. In order to understand better this subject, we have to make the problem of the EVIDENCE3, that is about our students that made the ICNE exam, and they give us the results that they obtain. In its scale, we have that they must obtain between 700 and 1,300 points. 700 is the lowest score that they can obtain, and 1,300 points are the maximum or the higher. First, we have to know the number of students, that is 135 in total. 52 students obtain between 700 and 1,100 points in the exam. 68 students obtain 1,100, between 1,100 and 1,200 points, and 50 students obtain between 1,200 and 1,300 points. Well, in this problem we use the circle graph, and this is because it's easier to see the distribution of the data of the table, of the chart, and we can see much better the average of the students. This is the end of our EVIDENCE3. I hope you like it, and thanks for watching.
See you next time.
See you next time.